A little bit about me. I'm Nikki. I did the Founders and Coders program last year, and I'm now working as a full-stack JavaScript developer with Dwill. And I'm also involved in the Node.js community in London, where I help to mentor and organize Node Girls. So for the past 4 months, I've been working with Dwill and Thomas Cook on a project using a completely serverless architecture. And I want to share with you what this involves, some of the things that we've learned, and hopefully give you a demo of what you can build with a serverless architecture. So who in the room's heard of the term serverless before? Can we have a show of hands? OK, so quite a few of you. But for those of you who haven't, the term can be quite misleading. And the first thing to realize is that there are still servers involved. So serverless doesn't mean that there aren't any servers. And I really like this quote. Kind of thinking about serverless like remote work, there are still employees. The first thing to realize about serverless is that you still do have servers. You just don't have to micromanage them and maintain them quite so much. So what does it actually mean? And so instead of having to deploy a single large server for your application, you instead have multiple event-driven stateless microservices, which are each deployed independently. So this means code that is run in response to events, which doesn't persist any data or doesn't use any persistent data, and it's highly modular. So why is this interesting? Why should you care? So when you're deploying a large server for an application, there's lots of administrative tasks that you need to think about. So dealing with scale, thinking about making the maximum use of your capacity, having to pay for idle time, and also just like boilerplate code that you need for things like monitoring and logging. And the important thing here is that all these tasks are completely undifferentiated. So they don't add any value to your business, but they take up valuable developer time. And with a serverless architecture, you don't have to worry about a lot of these things. So it comes with sort of batteries included. And you can spend more time actually writing code, creating new features, and delivering value. So how do you go serverless? So this requires changing the way that you think about how applications are built. So instead of having a monolithic architecture where there's different layers to your application, you instead have to adopt a more microservices-based approach. So this involves thinking about your code as small functions which each perform a specific task. And each of these microservices can be deployed, written, tested, and deployed completely independently. So you've written your application with microservices. How do you actually implement this? So there's several different options that you can choose from. At Thomas Cook and at Dwill, we've been using AWS Lambda. So what is Lambda? So Lambda is a compute service that's offered by AWS. And essentially, you just have to provide some Node.js code that's run on the AWS infrastructure. So the bare minimum that you need to provide is just a file with a function that exports a function called handler. And this takes 3 inputs. So an input event, which is what triggered your function. This can have different fields. A context object, which has information about the execution environment, and a callback function in the standard Node.js callback convention. And this Lambda returns a quote from the Star Wars NPM module, if you're a Jedi. So it might return something like this. So the cool things about Lambda are that it's got this pay per execution model. So you pay for every 100 milliseconds that your function is executed. So you never have to pay for idle time, which makes it really cost efficient. You also don't have to worry about horizontal scaling because you can get 100 parallel executions by default, and this can scale to millions. And there's also a really generous free tier on Amazon, so you can get 1 million free requests per month for the first year. So you can pretty much get started with just the free tier. There's also some other features like versioning, which I'll go into a bit later on. So Lambda by itself is really cool, but it only gets really exciting when you use it with the API gateway. So the API gateway allows you to expose public HTTP endpoints. And these can map to Lambda functions. So if you think about taking a Happy server or an Express server and you take each of your endpoints in your server, you create an endpoint on the API gateway, you take each of your handlers, deploy them individually as Lambda functions, that would be one way of taking your entire server serverless. So the API gateway also has this pay per call model, so you only pay for the number of times your API is called. And there's also other things like rate limiting, caching, cores, and versioning, which are all really useful too. And it all comes as a package with the API gateway. So the topic of this section is start it. So if you're thinking about starting a new project and you want to use a serverless architecture, what might your application look like? So this is an example of a really basic serverless application. So there's a UI, which is a React, it could be a React app or just an application which is served from an S3 bucket. This then makes requests to an endpoint on the API gateway. And this can then call Lambda functions. So you might have one Lambda which writes to a data store. So here, the S3 bucket is a data store. You might have another Lambda function which retrieves things from a data store. So this would be a really simple serverless application. So at Dwill and at Thomas Cook, we've taken this a step further. And we're running a GraphQL server as a Lambda function. So who's heard of GraphQL? OK, so quite a lot of you as well. But for those of you who haven't, a quick primer. GraphQL is a query language that was developed by Facebook. And it offers an alternative to a traditional REST API. So you can expose your entire backend through a single endpoint. And all the queries are specified on the client. And the server just sends back the data that the client has requested. So you only need to make one request to retrieve all the data that you need. So you don't have to have these multiple round trips to the server. And this makes it really great for like mobile connections. So this is the structure that we've been using. So there's a React app, which is served from an S3 bucket. This makes requests to the GraphQL endpoint. So there's only one endpoint. This triggers the GraphQL Lambda function, which can then call any number of other Lambda functions. So here we have one which queries an API, another Lambda which writes to a data store, and another Lambda which reads from a data store. So this is a kind of simplified version of what we're using in production. And unfortunately, I can't show you what we're actually building. But to give you an idea of what you can build, I'm going to show you in the next 10 minutes, hopefully, how to deploy a serverless app. And we're going to build a serverless jukebox. It's going to be a GraphQL Lambda function. There's going to be another Lambda which queries the Last.fm API to get song suggestions. It's going to be another Lambda microservice which writes the songs that you select to an S3 bucket. That's going to be your playlist. And another Lambda which retrieves all the songs from that bucket. So it's going to get your playlist back for you. And the front end is just going to be a React app. So I'm going to quickly move to the code. Cool. Can everyone see? Right. So the first thing I'm going to do is deploy the song suggester. So this is going to be the first microservice, which is going to query the Last.fm API and retrieve song suggestions. So here, the function is just 39 lines of code. All it does is it gets a query, which is going to be the name of the song that you're searching for, and a limit. So here it defaults to 10, and it just returns an array of songs with all these properties. So name, artist URL, and image URL. So I'm just going to deploy this now. npm run deploy. So the deployment is being done with an npm module called DPL, which was written by Nelson, who's in the audience. And what it does is it zips up your Lambda function into a zip file with any dependencies that you're using, and it uploads it to AWS. So here, Song Suggestive Demo v1 has been deployed to AWS. Great. So the next one is going to be the Lambda that writes to S3. So S3 save. This is also just 36 lines of code. All it gets is in the event is data, which is going to just be an object with the name of the song that you want to save and the name of the bucket that you want to save to. And it's just going to save a JSON file with all the song information. So I can deploy this as well, npm run deploy. And this is also just using the same npm module to deploy this function. So now that's on AWS, S3 save demo v1. And the last one is the one that retrieves all the songs from AWS. So I'll show you that too, from S3. So this one is also just 49 lines of code. It gets given a bucket, which you want to retrieve from. It lists all the objects, and then it gets all the contents of all the objects. So I'm going to deploy this to npm run deploy. So I know this is really fast, but all the code is on GitHub, and I'll tweet out the links later so you can all go and have a look in your own time. So that now this S3 get demo v1, this has also now been deployed. Great. So the last thing is the GraphQL server, serverless GraphQL. So for those of you who haven't seen GraphQL before, this might be a bit confusing, but so GraphQL allows you to define a schema for your data. And in the event, the client specifies a query, and this is resolved against the schema, and only the data that the client requests is sent back. And all the microservices that we just deployed are used in the schema. So here there's 3 things that you can do in this GraphQL server. You can make queries for suggestions, you can make queries for your playlist, and you can also make a mutation, which is adding a track to your playlist. And each of these queries and mutations use one of the microservices that we just deployed to Lambda. So now I'm going to deploy the Lambda. But the first thing I need to do is create the S3 bucket that's going to be used as the data store. So npm run create S3. This is creating an S3 bucket, which is going to be used as effectively like a database. So serverless database demo, that's now been created. And then now I'm going to deploy the Lambda, npm run deploy. So this is zipping up all the node modules that are used by the function. I'm creating a zip file, and great, that's now been uploaded as well. So the very last thing, so all the microservices have now been deployed. The last thing in the backend, the last thing that we need to do is create the endpoint on the API gateway. So I can also run that as a script. So npm run create API. So the real advantage of scripting all this is that you can make it part of your continuous integration flow, and you don't have to do it all manually. So you can do all of this on Amazon console, but doing it all manually means that you have to go into the console every time. And scripting it means that maybe you're using CodeShip, and you just push all your code to CodeShip. CodeShip will run your tests, and then it can deploy it for you. So what's happened here is this script has created a post endpoint on the API. It's connected it to the serverless GraphQL demo v1 Lambda that I just deployed before. And the very last thing is a test invocation. So to check everything's been connected correctly, I'm invoking the API with a query for all the songs that have the word stronger. And here it's returned loads of songs here, so all these suggestions. So great, the entire backend's been deployed, it's all connected, and now it's all working. So that's great. So the last thing we need to do is go into the AWS console and enable cross-origin requests. Oops. API gateway. So just refresh this. Oh no. Log in. So to enable the front end to be able to make requests to our GraphQL server, we need to enable cross-origin requests on the API. So here, this API has been deployed, the GraphQL endpoint's been created, it's been connected to the Lambda function. So that's all been done successfully. I'm just going to enable cross-origin requests. So this is going to allow us to get a public invoke URL. So I just need to redeploy the API. And great, this is a public URL that can be used by the front end to make requests. So I'm just going to copy this and move to the front end, serverless GraphQL app. Cool. So the front end is a React app. You can have a look at the code if you want in your own time, but there's a config file where I'm going to paste in the invoke URL. And so this is the API, and we're querying the GraphQL endpoint on the API. So I'm going to save that. And then I'm going to create the S3 bucket that's going to be used as the S3 bucket that's going to serve the UI. So npm run create S3. Oops. Run create S3. So this is creating an S3 bucket and enabling static website hosting. So this is the URL at which the application is going to live, hopefully in a very short time. So npm run deploy UI is going to deploy the UI. It's going to push. We're using Webpack and Babel to bundle up the React app and then upload it to S3. So this is bundling the app. There's actually two parts to the app. There's the actual app itself, and there's Graphical, which is a IDE for GraphQL. And I'm going to show you that in a second. And it's a really useful tool for developers when you're working with GraphQL to be able to actually try out the queries that your application is going to use. So I'm just going to copy this URL. Copy. And great, the UI has now been deployed. So I go to open a browser. I'm going to paste this in. So hopefully, oh, no, internet. Is it going to work? Is it going to work? Yes, okay, so this is an end-to-end app. We just deployed an end-to-end serverless app. Okay, so just to make sure it works, someone shout out the name of the song. Anyone?
Purple Rain.
Purple Rain, okay. Purple Rain. Yay, oh. Rain. Ooh, that's been added to our playlist. So now if I refresh, it should hopefully still be there. Yay! So our serverless app works. So yeah, you can go to this URL. You can add songs if you want. All right, so back to the slides. Oh, I was going to show you Graphical. Let me do that quickly. GraphQL. So Graphical is an IDE for GraphQL. So here you can test out your queries. So actually on GitHub, I've added some example queries to the README, and there's a full tutorial. So if you want to recreate this, you can. But this is a query for the same query that's being used by the front end. So I'm going to write Purple Rain again here. And these are all the songs that have Purple Rain as the name. And this is a query that's used by the client. So if the client only wants the name, you just request the name. And should hopefully only get the names. So it's a very declarative query language that you can use. And it's also self-documenting. So these are all the queries in the schema, and you know exactly the data that's being returned from the server. So this is a really useful developer tool, which comes just as a React component that you can use. All right, so quickly back to the slides. So yeah, these are the links. I'll tweet them out later. So we've been working with the serverless architecture for the past 4 months, and you might be thinking of trying it out too. So what are the good things about this architecture? And some of the things that we really like are that you can deploy each of your functions individually. So if you want to fix a bug, if you want to add a new feature, you can just deploy that one part of your application. You don't have to worry about deploying the entire thing. This also helps to keep each of your services really simple and really specific to one task. AWS also comes with a lot of infrastructure already. So for things like monitoring, you can use cloud monitoring and logging. You can use CloudWatch. You don't have to set that up yourself. And the free tier is really generous. So to get started with, it's more than enough. We also use versioning, so we run multiple versions of our Lambda function at the same time. So you can have one for your continuous integration and run a stable version in production, and this is really useful. Some of the things you should be wary of before you dive into serverless. So as each of your functions as you have more and more microservices, your architecture can get really complicated. And integration testing becomes increasingly important. Also, debugging can be a bit of a pain sometimes because the same event can trigger multiple Lambda functions. So actually figuring out where the error is originating can be a bit of a problem, but we're hopefully working on a solution for that this week. So some of the things that we recommend, so how to tame your microservices, keep all your Lambdas separate, have a separate repo for each Lambda. This means that your code is really isolate each microservice. Also documenting interfaces, so how your Lambdas communicate with each other. Make sure that's documented really clearly. And as I mentioned, having deployment scripts instead of manual deployments means that you can integrate it really easily into your continuous delivery and continuous integration. Architecture diagrams, this is really important. So we found that our architecture of our application changes every week. And so when you're trying to onboard someone or trying to explain the architecture, having good diagrams makes such a difference. And also the last point about latency, as your code base becomes more modular, you might have to hop several Lambda functions deep in order to actually execute something. And this can introduce latency into your system. So making sure that you don't hop more than 3 can help prevent those issues. So I hope you're interested and excited and intrigued by Lambda and serverless. We found it to be great to work with, and I hope that you think about using it for the next project that you start. We created some resources on Dwill, and this is all on GitHub, so go and have a look, try it out, and yeah, have a go, have a play. We've also created some modules, all open source to help with testing and deployment, so have a look at those as well if you're interested. So yeah, just wanted to say a big thank you to the rest of the team at Thomas Cook, so Nelson, Jimmy, Jack, and our boss Pascal, who really championed this architecture, so thanks to all of you guys. And yeah, thanks very much.